Hi, and welcome to my latest YouTube video. So in this video, I'm going to be showing you how to check for normality in the case of Pearson's correlation. As we all know, Pearson's correlation is a parametric test, and parametric tests have certain assumptions that need to be met in order for us to carry them out. So Pearson's correlation analysis also has an assumption. Actually, it has several assumptions, but the main assumption is the assumption of normality. There is a normal distribution of the data. So in this video, I'm going to be showing you how to check for normality using PSPP. So let's go ahead and do it. So here we have data regarding the mental health of senior citizens living in an old age home. Let's assume that I want to find out whether there is a correlation between the age of the respondents and their anxiety. But before I perform the Pearson's correlation analysis, I need to ensure two things. The first thing is that the variable should be in the continuous form, both these variables, and also I need to ensure the data is normally distributed. Of course, there are several other assumptions as well, but we are only going to look at the normality assumption in this case. So let's go ahead and do that. First, we need to go to Analyze, go to Descriptive Statistics, click on Descriptives. Now here we need to select the two variables. One is age and the other one is total anxiety 2. Both of them are in the continuous form. Now I don't need mean, standard deviation, minimum or maximum. All I need is kurtosis and skewness. I click on both of them and click on OK. So now we have the kurtosis as well as the skewness value, and we need to now interpret them and find out whether the data is normally distributed. So first let's start with age. So the kurtosis value of age is minus 0.68. So minus 0.68. I divide that by the standard error, which you see here is 0.65. So divide that by 0.65. So we get the value of minus 1.04, which is within 1.96. Only if it exceeds 1.96, we would say that the data, there's a problem with the kurtosis. But right now it's within the acceptable range. So kurtosis for age is okay. Now let's look at the skewness for age. This is 0.51, and we divide that with the standard error of skewness, which is 0.33, and we get a value of 1.54, which again is within 1.96. So we are safe with regard to the skewness as well. That is with regard to age. Now let's look at anxiety. So the kurtosis value for anxiety is minus 1.05, and we divide that by the standard error, which is 0.65, and we get the value of 0.06, minus 0.06, which again is within the acceptable range. Then let's look at the skewness for anxiety, which is minus 0.55. We divide that by the standard error, which again is 0.33, and we get a value of minus 1.73. Again, very close, but it does not exceed 1.96. So in both these cases, we can say that the skewness and kurtosis are fine, and that the data is normally distributed. And we can go ahead with the correlation analysis. So now that we found out that the data is normally distributed, let's go ahead and quickly perform the correlation test. That's the Pearson's correlation. We go to Analyze, we go to bivariate correlation, and here we select age, which is the first variable, and the other one is total anxiety, and then we click on OK. We can also select another option here, by the way, which is called flag significant correlations. I hope you can see that. So click on that and then click OK. Now let's go to the output. So here we have the correlation test results. So here you can see that there is a negative correlation between age and anxiety. That is, those who are older seem to have less anxiety. And this correlation is also significant at a marginal level. That is 0.080, which is less than 0.10. So it is statistically significant at a marginal level. So that's about it for this video. I hope you found this video useful. I have a complete video on how to perform a Pearson's correlation analysis as well as how to interpret it. I will leave the link of that particular video in the description. So all the best, and thanks for watching.